Okay, hello, welcome back. This is 7.2 now, college algebra, solving systems of equations, now bigger systems, bigger and bigger. I remember reading some stuff about the space shuttle. They would have hundreds of equations and hundreds of unknowns, and they had to use like very high-powered special techniques for solving those systems. There's an entire class dedicated to that sort of stuff. If you kept taking math, if you're really in the math, you can take that class eventually. Anyways, I try to give you a nice kind of algorithm for solving these things. A lot of the times, though, you can kind of solve them by the seat of your pants just by kind of chipping away at the unknowns, but I'll try to provide you with some direction, right? So anyway, solving, how is this going to work? I kind of first choose a variable to eliminate and basically produce a system of equations with two unknowns, two equations, two unknowns. So first eliminate one variable. I'll just write one var. That will produce produce a system of two equations, two unknowns. Then you, of course, solve it. And then the rest is just back sum. Okay, so what does that mean? Okay, so let's take a look. Right? These problems are a little longer, and the sad part is because we're humans, we often make little tiny errors. So that's the hard part. It's just making these silly little mistakes, and it ruins the whole problem. And it's like, where's my mistake? And if you're having a bad day, it's almost impossible to find your mistake. Okay, just copying down the problem is sometimes an overwhelming experience, depending on how your week's going, right? So I would advise you, once you get it copied down, look at your paper and make sure you have it copied down correctly, okay? So that's what I'm doing right now. Okay, so the first thing to do is to produce a system of two equations and two unknowns. And what I say is to pick a variable to eliminate. So for instance, I'm going to eliminate y. Eliminate y, and I'll end up with two equations in terms of x and z. And that'll be a problem like the 7.1 section that we already did. Okay, so how do I eliminate y and get two equations in terms of x and z? So pick two equations, 2x plus y minus 2z equals -1. And I'll pick the second one, 3x minus 3y minus z equals 5. Okay. Then I'm going to use the addition method. So if I multiply the first guy by 3, I'll end up with something that eliminates y. Right? So 6x plus 3y minus 6z equals -3. And 3x minus 3y minus z equals 5. Okay. I'm going to add those together. So I get 6x plus 3x is 9x. The y's cancel, and then minus 7z equals 2. Okay. So there's my first equation. I need one more. So what I do now is just borrow two different equations, or you could borrow the first one again, 2x plus y minus 2z equals -1, and then I'll borrow the third. You don't use the same two equations, that's what I'm saying. Plus 3z equals 6. Like one can be the same, but you're going to have to pick another one. Okay, so I'm going to multiply the top guy by 2. Okay, so I'll end up with 4x plus 2y minus 4z equals -2. Then I have x minus 2y plus 3z equals 6. And then add those together. I'll have 5x minus 1z equals 4. And now I have my new system of equations, right? So I have this new system. the 9x minus 7z equals 2, and 5x minus z equals 4. Okay, so I can solve this using the methods from the last section. I can solve it. So I'm going to multiply the bottom guy by negative 7. 9x minus 7z equals 2. I'm hoping to eliminate the z's. Negative 35x plus 7z equals negative 28. Okay. So I'll have negative 26x equals negative 26, and so x equals 1. Okay. And now it's all back subbing. So you could plug x equals 1 into any equation that has just two variables. So I'll plug it into the first one I see, the 9x minus 7z equals 2. So 9 minus 7z equals 2. So negative, I wrote zz, negative 7z equals negative 7. And then, of course, z is 1 as well. Okay. And then I have to go back to any equation that has all three variables. So I'm back subbing, I guess, at this point. So I need an equation with three variables from above. So try 2x plus y minus 2z is negative 1. I just took the first one from the system. 2x plus y minus 2z is negative 1. Okay. And then plug in the x equals 1 and z equals 1. So I'll have 2 times 1 is 2, plus y minus 2 times 1 is minus 2, negative 1. 2 minus 2 is 0, so y must equal negative 1. And so we'll have our solution, 1, negative 1, 1, and this time it's an ordered triplet. So the geometry is a little different now. You're in 3 dimensions as opposed to 2 dimensions. And each one of these equations, instead of a line, represents the equation of a plane. So like a piece of paper floating around in your room somewhere. Okay. And when you look for solutions, you're looking for where these planes or these pieces of paper, if you want to think of them that way, intersect. Okay, let's try another. So x plus z equals 3, x plus 2y minus z equals 1, 2x minus y plus z equals 3. Okay, so first off, I want to create a new system by eliminating a variable. The first equation already has the y eliminated, so let's choose to do that. And that way we'll already have one of our equations, the x plus z equals 3. And then all we have to do is eliminate y from these second 2 equations, and we'll have our second equation, and we can solve that system. Okay, so I'm trying to get rid of y, right? So I'm going to multiply the second equation by 2. And then I'm going to add the equations together. Okay, and there is my second equation in terms of x's and z's. So my new system is x plus z equals 3. That was just given from the original system. And then 5x plus z is 7. Okay. And then solve that system. Okay, so I'm going to multiply, I guess, the second one by negative 1. So I have negative 5x minus z is negative 7. Add them together. Negative 4x equals negative 4. And then solve. So I'll have x is 1. And then, of course, do all your back subbing. Right now I have x is 1. Okay, so I'll plug that into any equation that has 2 variables, including x. So x plus z is 3. I'm plugging in 1 for x. So z is 2. And then I have to get an equation with all three variables for the y variable. So I'll choose x plus 2y minus z is 1. So I have 1 plus 2y minus 2 is 1. 2y minus 1 is 1. So 2y equals 2 and y equals 1. So my solution, 1, 1, 2. Make sure you put them in the right order, x, y, z. Okay, so some of the equations will kind of already be the way you want them. Okay, so when that happens, it's kind of like the procedure I've given you is easier than what the original problem is. Like the original problem that I gave you, number 6, took the most work. Okay, for number 12, part of it is kind of already done for you, so the process doesn't look exactly the same. And what I'm saying is that's going to happen. Okay, the easier the problem, the less likely this process will adhere to the problem. Okay, and usually in those cases, it's just a matter of half your work is done for you. Just kind of do some substitution and get your answer. Okay. Okay, so hopefully that'll be good enough, and that'll get you through on your way to getting the problems done. Let's look at one of the kind of applications I like. Basically, if you know 3 points, you can create the equation of a parabola that passes through the 3 points. Okay, so in these questions, they're going to want you to find the quadratic, and of course that means the parabola y equals ax squared plus bx plus c, which passes through the points given. So problem 20, they give us the points -2, 7, 1, -2, and then 2, 3. And you could always pull this off so long as the points don't have the same x coordinate. Okay, so if somebody randomly gives you 3 coordinates, I believe you're going to be able to find a parabola that passes through those 3 coordinates. Well, I don't know. I kind of want to take that back. I don't know if that's true. It seems like it should be true, though. Okay, it really seems like it should be true. It seems crazy, but it seems true. Okay, so how do I get this into kind of the context that we're working in with systems of equations? Well, what you're going to do is plug in -2 for x and then 7 for y into this quadratic here. Okay, so if you plug in -2 for x, you'll have a times -2 squared. -2 squared is 4. Okay, so you have 4a. And then plus b times -2. That'd be -2b, right? So let's just put -2b, and then plus c. And that'll equal y, which in this case is 7. Okay, so you're forming equations based off of these x and y variables by plugging those x and y variables into the equation y equals ax squared plus bx plus c. And you'll end up with 3 equations in terms of a, b, and c instead of x, y, and z. Okay, so let's do the second one, plug that stuff in there. I'll have a times 1 squared, which is just a, plus b times 1, which is just b, plus c, and that'll equal y, which is -2. And go on to the third one now, plug that stuff in there. So I'll have a times 2 squared, which is 4a, plus b times 2, which is 2b, and then plus c, and that'll equal the y value, 3. Okay. And there's our system. Okay, now we can solve for a, b, and c, and those will be the coefficients on our parabola. Okay, so let's do that. First, I'm going to choose a variable to eliminate. I'm going to get rid of the c. That'll be the easiest one to eliminate. Okay. So I'll work with going 2 equations at a time. And I'm just going to go ahead and multiply the second equation by a -1. Okay, that'll eliminate some of my writing. And it will also eliminate c, right? Okay, so I'll have 3a minus 3b equals, I guess that's 9, sorry. Okay, so that was from the first 2 equations, and I'll use the second 2 equations. Again, I'm going to multiply a plus b plus c equals -2 by -1 to create a cancellation. Okay, so I'll have 3a plus b equals 5. So I'll have my new system then. 3a minus 3b equals 9, and then 3a plus b equals 5. I'm going to use the addition method. So you can always divide as well instead of multiplying. So I'm going to divide the first equation by 3. Okay, so I'll have a minus b equals 3, and then 3a plus b equals 5. Okay, so I have 4a equals 8, and I got my first variable. So a is 2. You could back sub now, so 3 times 2 minus 3b equals 9, just taking the first equation I saw. 6 minus 3b is 9, and then negative 3b is 3, and so b is negative 1. Okay, and then for the final back subbing, and again, you don't have to number your steps or anything, I just do that for your benefit. Take any equation that you can solve for c. Okay, so we'll have 4 times 2 minus 2 times negative 1 plus c is 7. So 8 plus 2 plus c is 7. 10 plus c is 7, and c is negative 3. Okay, so we got all of our variables. Now we just form our parabola. So hence, our parabola is, and now we just plug in the a, b, and c. So y equals ax squared. So again, our a was 2. So we got 2x squared plus bx. Our b is negative 1, so minus x. And then plus c, which is minus 3. And that's our equation that goes through those 3 points, which is a parabola. It's a pretty awesome technique. An interesting idea somebody came up with. Okay, so that'll do it for this section. Get in there and get that homework done. I'm sure there's plenty of work to do in there. And thanks for watching. We'll see you next time.